Every survival game begins with nothing, and the promise that you can build everything. Survival games are built on simple ideas, but turning those ideas into a working game is a whole different challenge. If you've ever wanted to build your own survival game from scratch, you're in the right place, whether this is your first time opening Unity or you've already built a few projects and want to go deeper. In this tutorial series, we're going to create a first-person survival game in Unity, starting from an empty scene and building real systems step by step. I'll explain why we're doing this, not just what buttons to click, so beginners can follow along and more experienced developers can adapt the systems for their own games. We'll cover everything a survival game needs: interacting with the world, managing inventories, crafting systems, and tracking player statuses so we can measure their ability to stay alive. In this first video, we're jumping straight in by setting up a first-person controller and building the foundation for interacting with objects in your environment. Let's get started. To start out, we're going to have a fresh Unity project. I'm starting with an HDRP, or High Definition Render Pipeline core project. Just give it a name, choose where you want to save the project, and click Create Project here. I have already created my project, so let's see what it looks like. Okay, great, here we are. So let's get our bearings. I assume you have some familiarity with Unity, so I won't go into a lot of detail with the basics. But I will show you what it starts with here and get into what we'll add to get the controller working. So we start with a pretty sparse scene. It has our main camera, the sun or our light source, and a sky fog volume. We can safely leave all this alone, and let's start by giving our character something to walk on. Right click on the hierarchy window, select 3D object, and let's add a terrain. This is a great space for creating a survival crafting sandbox game, but we really need our player so we can start moving around and get into some gameplay. Luckily for us, Unity has some starter packages that include a really great first-person controller for free. First thing we want to do is open our package manager. If you don't have the tab already, we can find it here in the Windows tab. Just select it and dock it in with the Game and Scene tabs for easy access. Next, we need to download and install the starter package for our first-person controller. This can be found in the Asset Store. You can either search for this under Unity Asset Store, or there's a link here as well. When we click that link, it opens up the Unity Asset Store for us. Just search for the starter assets and find this one here, the first-person character controller. Since we navigated here from our Unity project, you'll notice that we're already connected to our account. This is great. If you navigate just from the web, not from your project, sometimes you have to log into your account to add this asset to your account. This is a free asset, and it's a really great controller. Go ahead and add it to your assets. Now, when you go to the Package Manager tab, we can locate this asset under My Assets. Just search for Starter Assets, and we want the first-person controller. Now, let's import it into our project. It will give us this options list. I don't need the environment parts or the mobile parts since I'm working on a desktop game. This may ask you to validate this depending on what Unity version you're using. I'm currently using Unity version 6.3, which is the latest version when I'm uploading this video. Once you have it validated, we're ready to go. Alright, the first thing we're going to want to do is locate our prefabs. Find the Starter Assets folder in your Assets and go to the Prefabs folder. What we want is the player capsule. Let's drop that in on the terrain that we created earlier. Just drop it into the scene. Next, we need the player follow camera. Just drop that into the hierarchy. This uses Cinemachine, which is an amazing asset that helps control our camera for us straight out of the box. We need to tell it what to look at and what to follow. Our target is the child of the player capsule object. This object, player camera root. Just go ahead and assign this to the follow and look of the player follow camera. Great. Now, when we hit the play, you'll see that we already have a functioning first-person controller. Congratulations! We already have a fully functional controller that immerses us into the world we just created. We can walk around using WASD and jump using the spacebar. This is a built-in functionality, and this already functions like most first-person games in the industry function. Walking forward with W, backward S, strafing with A and D, as well as sprinting while holding down the shift button. To get out of play mode, just hit the escape button so you can see your cursor, and then we can just stop. You can also get out of play mode with Control P. Now, let's tackle interacting with objects. To start, let's place something to interact with. We can just add a cube. In the future, this will be replaced with items that we may actually want to interact with, like trees for wood, or bushes for fiber, or fruit, rocks, and so on. But for now, a cube will work just fine. Let's go ahead and rename this to Interactable Object. And let's change the tag on it to be interactable. This is key for us. In the code, the tag is what we'll be checking to see if we're looking at an interactable object or not. So let's create an interactable tag, and then we'll set the interactable object to interactable. Alright, let's start with getting our player to recognize when they're looking at an interactable object or not. First, let's add a UI canvas panel, and we can use the panel image as our center marker. This will just be a good way for the player to see if they're looking at something so they can interact with it. Now we can add an image to the center of the panel and scale it down a bit so we get a center reticle effect. And there. Now we have something to show us exactly where we're looking. Perfect. Next, we need to shoot out a ray from the camera to see what's in front of us. Let's make a custom script. We'll call it player, and we'll add it to our player capsule. Okay, now let's open it up in Visual Studios by double-clicking on it and get it functioning. First off, let's get the transform that will be controlling where our ray shoots from. The main camera is perfect because this transform is manipulated by the virtual camera and gets us the perfect position that we're experiencing the game from. So we can get a reference to the main camera transform using camera.main.transform. I like to add my reference in their own method to keep things organized. Next, we can add the onDraw gizmos method. This is a built-in method that's just for us, and it works in the edit scene. It'll help us visualize how far out and how well we are being able to interact with objects. To this end, let's give us a float that will give us a distance for interacting and make it serializable so we can adjust it in the editor. Okay, now we can give the gizmo a color. Let's use red. And finally, draw a line. The gizmo's draw line method takes in a starting position. We'll use our camera transform.position, and then it takes in an end position. We'll first have to start with our cam transform.position, and then we'll add the cam transform.forward direction times the distance. This will give us a line that starts at the camera position and then goes to a position the interaction distance away from our position in the direction we're facing. Great. Now let's see how it works. Oh, and don't forget to set the interaction distance. Let's go with 3. Okay, and alright, this is working great. This is rotating with our camera and looking up and down when we need to look up and down. Perfect. Now let's get the basics of actually shooting a physics ray out and make contact with our environment. Okay, back in our player script. let's take a look at shooting a ray out to check what's in front of us. We'll do this in the fixed update. First, we need a raycast hit variable to store our hit information from the raycast. Next, we'll put it in an if statement to give us information only if our ray that we shoot out hits a collider. We type in physics.raycast, and then we'll give it a starting point like we did for draw gizmos. So cam transform.position. And now we give it a direction, so cam transform.forward. Next, our out hit that we created to gather the information from the raycast. And finally, a distance that the ray will go. So we can use our interaction distance. Now we're shooting out a ray in the fixed update, and if we hit something, this will trigger. Alright, great. Now we can have it do something to test it out. Let's check to see if what we hit was interactable. With if hit.collider.gameObject.tag is equal to interactable, then if it is, we'll just print something like interactable object in range. This is the first step to actually interacting with something, but it's an important step. Great. Now let's see how it's looking. Okay, great. So we can see this is working. You can see that if you look at the object, it's printing out our message. And you can also see that if I move out of range like this, it's no longer printing our message to the console, even though we're still looking at the object. This is exactly what we need for our survival game. So we need to be in range of an object to interact with it. There's one more thing I'd like to adjust to make it a little bit more efficient. We can make it so the ray we're shooting out only registers a hit when the collider it interacts with is on a specific layer. We can give it a layer mask. To start with, let's make a new layer called the interactable layer. To do this, we can start by selecting our interactable object in the hierarchy window. Now, in the inspector window, we can adjust the layer. We can see there currently is no interactable layer yet. We need to make it. So let's choose Add Layer. In here, we choose an empty slot and type in interactable, then press Enter. And we go back to the hierarchy window and select the interactable object again. Now we need to set this object to be on the interactable layer. This is an easy step to forget. Don't ask me how I know. Okay, now back into our script to utilize this functionality. To do this, we open back up our player script. First, we need a layer mask variable that we will make a serialized field so we can change it in the inspector. We can call it the interactable layer. Now we go to our raycast and just add it to the end. And that's it. Now the raycast will only interact with the colliders on this layer. Let's go back and see if this is functioning. Back in the inspector, we need to set this layer on our player first. Now let's give it a run. And look at that, you can see that this is working just like before. So there's actually no change, and this is good. But we can do a little test here. If we go to our interactable object and put it on the default layer and run it again, okay. There, you can see that even though it is tagged as an interactable object, there's no interaction from our raycast. See? We're getting no feedback on our console window. In fact, we can go ahead and put this interactable object back on the interactable layer and then remove the tag check in our scope. We don't need to even check the tag if only our interactable objects are on the interactable layer. Okay, let's go back in and check this out, and we should still see our message. And there you go. Congratulations if you made it this far. Think about all the possibilities that there are for our little game. It's just a blank slate, and there's no limits to where we could go. In our next tutorial, we'll make a small inventory and make interactable objects actually do something when we choose to interact with them. Thanks for watching, and if you're getting something out of this series, please hit that like button and make sure you subscribe so you know when the next video is up. I'd love feedback from you guys to know what you may want to see for future tutorials in this series. Just leave me a comment, and if we get enough likes and comments, I'll know which direction to take this. Bye for now.